Welcome friends. Today I shall discuss about specific heat of gases. Now we all know that when a gas is compressed by applying pressure, then its temperature increases, though no heat is supplied from outside. In that particular case, dq equals to 0. So dH, that is specific heat S, becomes dq dt, that is 0. Okay, now if a gas expands, then the temperature of the gas falls down, that we all know. In order to keep the temperature constant, in this case we have to supply some amount of heat from outside. So in particular case, when a gas expands, our main aim is to keep the temperature constant, that is dt is 0, and in that particular case S becomes infinity. So there we see that if we either keep pressure or volume constant, sorry, by mistake, if we don't keep either pressure or volume fixed, then specific heat of the gas becomes 0 to infinity, that is it can lie between 0 to infinity. So this is not possible. So for simplicity we have to keep either pressure or volume constant, and there are two ways: either keeping pressure constant, if the temperature of the gas increases then its volume increases, and if we keep volume constant, then the temperature of the gas is proportional to pressure. So there are two ways. So for this reason, a gas exhibits two type of specific heats. One is specific heat at constant pressure and another is specific heat at constant volume. And if we consider 1 mole gas, then it is called molar specific heat at constant pressure, that is Cp, and another is molar specific heat at constant volume, that is Cv. So what will be the definition for 1 mole gas? Molar specific heat at constant pressure is the amount of heat required to raise the temperature of 1 mole gas, 1 mole gas, 1 mole gas to 1 degree Celsius by keeping pressure constant. This is the molar specific heat at constant pressure. And similarly, the amount of heat required to increase the temperature of 1 mole gas to 1 degree Celsius by keeping volume constant is known as the molar specific heat at constant volume. Or more general mathematical form, we can say Cp, this is equals to dq dt pressure constant, and Cv, this is equal to dq dt volume constant. Okay, thus we see that a gas has two type of specific heats and their definition is given. Now one thing has to be remembered, that which one is greater, Cp or Cv? This is an important question to all HS and graduate students, that which specific heat is larger and why. Now let us explain this. Suppose we want to increase the temperature of 1 mole gas by keeping volume constant. So if volume remains constant, then dV equal to 0. So if we increase the temperature of 1 mole gas by dt degree Celsius, then at constant volume we can write dq equal to du equal to Cv dt. Now if the same gas, if we take same gas and we want to increase the same amount of temperature, that is dt, at constant pressure, then we can write dq equal to du plus pdv equal to cpdt. So when volume is constant, the entire heat is used to increase the internal energy of the system. But when pressure is constant, a part of the heat increases the internal energy of the system and rest performs the work. So we can easily write these two equations. Okay. So from the above expressions, it is very clear that CPdt is always greater than CVdt. That is, we can easily tell Cp greater than Cv. So this is our result, that molar specific heat at constant pressure is always greater than molar specific heat at constant volume. Okay. Now later we will prove that for 1 mole perfect gas, Cp minus Cv, this is equal to R. This we will prove in the next lecture. Okay, thank you.